Today I'll be discussing re-conductoring, specifically how advances in LiDAR and CAD technology have transformed the way that re-conductoring studies are considered and actioned. There are now 4 key areas which allow us to perform re-conductoring more effectively. The transition from deterministic to probabilistic design codes, which take into account the actual geographic location and altitude, terrain type, and adjacent spans with any associated angles of deviation. The larger selection of conductor types and sizes, including HTLS, high temperature, low sag conductors. The availability of specialist engineering tools, such as PLS CAD, which provide precise calculations of applied loadings and available structure capacities using these probabilistic design codes. And the availability of LiDAR datasets to populate these engineering tools and allow exact calculation of structure loadings and capacities. The availability of these 4 items means the electrical load transfer capacities of multiple conductors and their site-specific loadings can be accurately determined. This means any structural reinforcements required can be identified and scheduled. Secondly, computer modelling can objectively rank the different options, each with a specific electrical capacities, structural loading reinforcement schedules and costs. One of the key improvements of this approach is that specific reinforcements can be clearly defined. For example, where previously analysis may have shown that all structures within 80% of allowable wingspan required reinforcement, it's now possible to identify only the specific structures that required reinforcement. More than that, the use of structural analysis tools such as PLS pole and PLS tower can drill down to identify only the failing members within those selected structures, even detailing the precise mode of failure for each member identified. Taken to the extreme, this may mean that an earlier analysis which showed 90% of tangent towers required reinforcement following a re-conductoring now shows that only one structure requires reinforcement, and for this structure there is only one failing member. That member is failing in tension, and that failure can be resolved by replacing the existing mild steel bolts with high yield bolts of the same diameter. The analysis accurately identifying the remediation required and significantly reducing potential capital cost. So, in conclusion, the switch of design methodology, the availability of engineering analysis tools, the LiDAR data to populate these tools, and the profusion of available conductor materials and types means that there are more viable options available. Multiple conductor systems can be considered and a precise scope of work and reinforcement requirements identified. Engineers can now receive a detailed schedule of electrical load transfer capacities, demonstrate how this affects transmission losses and the effect on kilograms of CO2, which works are required and the duration of those works. It is also possible to provide accurate costings for each option. Armed with this information, a network operator can be confident the most appropriate re-conductoring option has been selected. The evolution of geospatial data, combined with advanced tools and software, has meant more precision is available when completing a re-conductoring study. This in turn means that in many cases increased line capacity is available without the expense of major capital works. For more information, take a look at www.nmgroup.com. Find us on LinkedIn or Twitter.